Okay, I wanted to go over the other part of the significant figure notes. And in Schoology, there's part one, which is this sheet. And I put it in for the 30th to the 2nd. And so this is the second. I'm going to start the second part. But we were talking about why we do significant figures. And it's because it represents how many numbers are measured. And we're doing multiplication here. And we have a major rule that all non-zero numbers are always significant, and that when you are dividing or multiplying with different number of significant figures in each measurement, then you're going to round the answer to the lowest number. Okay, now that's going on this part of the video. And then we went over the zero rules. And remember that these zeros are in between. They do and they are significant. If you got zeros in front with a small number, they're not significant. And when you have zeros that are after non-zeros, but you have a decimal, then they are going to become significant. So I wanted to just reiterate all this because I wanted to also show you what the answers are, and to emphasize that, like, when you look at these all have smaller numbers. So you're only going to be doing the non-zero numbers. Okay, but if you have zeros after it, like this one, you're going to include not only the non-zeros, but the zeros at the end. These small numbers, these zeros in front, are not significant. Okay, when you have a large number without a decimal, then only the 7 is going to be significant, not any of these zeros. Okay, so if you look at the answer, this is just one. We only have these two. Here we have all of them because it's a large number, which is like it's got to be 1 or higher. And 84.1 with 4 zeros is going to make it 7. So take a look at all of these, and then if you want to send me a message and say, why is this number only have 5, then we can text back and forth about the reasoning. But just to look at this one, why it's 5 is because there's no decimal. So you're going to go between the non-zero to the next non-zero and include everything in between it. And that's why there's only 5. These zeros are considered placeholders. The ones where you're in front or at the end without a decimal, these zeros are called placeholders. These zeros that are placeholders are ones that are never significant. And they could be on a large number without a decimal at the end, and they could be the zeros in front of a measurement of a small number. These zeros in front, these zeros at the end with a number that doesn't have a decimal, these are considered not significant. They're considered placeholders. Okay. Now, as we go into part 2, that's the next page. And so for you guys that have been absent, I actually started part 1 on Tuesday and Wednesday, and then I finished up part 2 today. And this is talking about multiplying and dividing. It's just another set of examples, just like the bottom of part 1, just reinforcing the same thing, because multiplication is going to be something we're going to do all the time. We're going to be calculating heat and calculating different kind of wavelength and frequency values, and all other kind of calculations, and we're going to be multiplying a lot. So when we do this, you're going to remember that it's the least number. So this one has 3 because the inner 0 is sandwiched, so that's going to be 3. But when you have a number that's large, and you have the 2 in front, the 32 is, but the zeros are not because there's no decimal. So this is just going to be 2. Then you're going to be only keeping 2 in your answer. So you're going to keep the 9 and the 8, but you want to make it still 9 million. So you're going to write the 9 and then the 8 and make the 9 as big as millions with all these zeros. And when you have a large number, you're going to put zeros in its place to make sure it's the same size number. In other words, you're rounding to the 8 and putting all the zeros in place and saying it's just around 9,800,000. Okay, now when you do another one, just to reinforce this, is when you have the 480.00, the decimal makes all these significant. That would be 5. And then we have 23,000, again, like the 32,000. There's no decimal, so it's just a 23. So this is just going to be 2. Okay, so when you have a small number less than 1, you are going to be not including the first 2. These are placeholder zeros. So you're going to start at this 2 because it's the first non-zero, and then that 0 here, but then you look beside it because we need only 2. So this 8 is going to make this 0 go up. And so we're going to make it 0.02 and then round up that 0 to a 1. And then all these numbers are just going to drop. You're not going to put anything in its place because this is the size number. It's 0.021. When you have a large number, you're going to have to put zeros in its place to make the number that big. When you have a number less than 1, you're just going to drop them. Okay, drop them and ignore them and erase them and not use them. Okay, so we did talk about the rule, just reinforcing it with this second page. And when you multiply and divide, you round to the correct number of significant figures as the lowest number of Sig Figs in the numbers that you're being combined or calculated with. Okay, so we're going to use the lowest number with the numbers that are used here. Okay, now when you add and subtract, it's a little different. Okay, and I want you to realize that when you're adding, it really values on the actual places of the decimal because you have to physically put them in place. Now, I know your calculator can give you the answer for each of these, but you literally are going to look at adding like you're back in first grade math, and you have to line it up and talk about how you carry the 1 and everything, and you add it up. Now, I know the calculator can do it, but what it is you're looking for the basing your answer on where every one has a measurement. Okay, see, after this 0.3, we don't know what's measured there. Okay, after this 8, we don't know what's measured there. So since we don't know what those numbers are, and if you add them together, then you really can't trust the 5 and 9 because not all 3 numbers have a measured value. So what the rule is that when you're adding, subtracting, you're going to round to the correct number of decimal places as the number combined with the least decimal places to the right. Okay, so what that means is, okay, as you go to the right, there are 4 places past the decimal, but in the next measurement that you're trying to add, the scientist didn't go any further than 1.2. So we don't know what those 3 numbers are. And since we don't know what those numbers are, scientifically, we cannot use them. And we have to stop our rounding to where both numbers, or if you have all 3 here and all 3 as well, are contributing to the added answer. So literally what's going to happen is you're going to put a line where the entire column has numbers. Like here you have a 3, but there's nothing here, so you can't use that 3. When you do the 0 and you go to the next number, there's nothing here, so we don't know what that is either, or this one. So these columns, we don't know what these numbers are. There's nothing there. So the least number to the right is this second row number. It ends at the 1s. And so that is going to be where you base your rounding, and you're going to stop at the 1s and go to 291. Your answer here is 291 because the 1 is being added with the 4 and the 5 and the 2. All 3 numbers are adding to get that 1. Okay, so since they have measurements, they have values there, then you're going to be able to trust to the 1s and no further. Okay, if you kind of follow what it says, you're going to go and base it on the measurement that has the least decimal places to the right. And if you look at the first one, you have the least number of going 2 places past, but this goes 4 places past. This is the least number, so you go ahead and stop at 2 places past, and you look to the right and see if that number can round it up. This one didn't round it up. This 1 didn't round up. So, but this 7 does. So we're going to do, and it's already subtracted for you. So the answer is 40.34. And so you basically stop there. That's the answer here. Okay. So this one, I was trying to show you that we're going to stop here because this is the last column where all three numbers are adding together, but the 5 makes the 8 round up. So the answer is 14.9. Okay, here it's 14.2. This one is really totally different than the multiplying and dividing. Okay, you don't care that there's 5 sig figs. You don't care that there's 2. You care where they're placed. Okay, so you only go until so far based on the least measured number to the right. Okay, now with the homework, just to go over with the homework, I'm not going to go over a lot of examples because it's already, I can only record like 15 minutes on this document camera that I'm using. Okay, so on the other side, I want you to work on telling me how many sig figs they are. Okay, this is the first page. And then you want to go ahead and add these together and tell me where the least measured numbers are in significant digits and give me your answer, and do the same thing adding these together. You actually have to calculate them, and if you want to use your calculator, you can. You can also just add them by hand. But you want to round to the least number of places to the right. Okay, and these are the only 2 adding ones in the homework. So I'm not really emphasizing the adding rules. I really want you to really work with the multiplying and dividing. So you have to divide 86 by 1.223, divide it up, and get your answer. And because this only has 2 significant digits, then you're only going to round to 2 digits here. And it doesn't matter where they're placed. You're just going to take the first 2 digits in your answer. Okay. Then you base it here with 2, and this having 4, you're going to round to 2. So you have to calculate it, times the numbers and calculate. And this really should be a millimeter. I don't know why I didn't have the same unit. These should both be millimeters. Okay. And then you multiply these together, but this one has 3 and this one has 4. So here you're going to round to 3 digits. Okay. So work on these 3. And then I set up the next page where everybody's multiplying or dividing, but I want you to tell me the number of sig figs underneath each one. And then I give you the answer. You just go ahead and decide what you're going to round to, and then try to also label the units as well. So there's like, I don't know, eight examples here with a bunch of ones that you fill in the sig figs, and then you round to the least number. Okay. So you try this page. And then we have this page where you do some more sig figs. Tell me that has so many. This one here, 34.0. That O makes it significant, so that's going to be 3. And you could keep doing more. Here's some multiplying. You tell me how many sig figs it has, and then round it to the right answer. This one you're dividing. And then I also put some reading scale questions because we're going to have that on the quiz. It's planned for Tuesday coming up, but if you've been absent, you'll be making it up when you get back. Okay, please email me or text on Remind what your questions are. Okay, hope everything's going well, and please keep in touch with me. Talk to you later.